Hi guys, and welcome to week 3. Wanted you to know that I was praying for you, and I'm loving you, and I'm missing you. So just know that I'm praying for you. This section is kind of long and a little bit hard. So there's lots of calculator keystrokes, a lot of intricate calculators. So if you have any questions, please don't hesitate to ask me. All right, so in 9.3, we're going to talk about different types of variation. This can be very confusing because the symbols can be very confusing. It's important that you know the symbols. You guys just turned in section 9.2. The first ones I gave you was matching 1 through 8, I believe, had some of these symbols, and you really need to know what they mean. Otherwise, this is going to be very difficult for you. We're going to find and interpret a coefficient of determination. We're going to find an error of estimate, and we're going to construct a prediction interval. Now, lots of these formulas are very intricate. Now, we can use our calculator for them, so we don't have to do it all by hand, but it is very intricate, so stay with me. So, variation about a regression line. Variation about a regression line. There are 3 types of variations about a regression line. There's a total variance, an explained variation, and an unexplained variation. Now, to find the total variation, we first have to calculate the total deviance, the explained deviation, as well as the unexplained deviation. So on this next slide, we're gonna talk about that. Now, the total deviation is y sub I minus y bar. It's important that you need to know what this is. We were first introduced to these symbols in the last section. Y sub I is the y value that is paired with the x value. It's the given data value. It's what's usually in your list 2. So we're given some x and y value that we put into list 1 and list 2. That's your y sub i's. Those are your list 2's. Those are the data values. Now, from before, you know that x bar is the mean of the x's. Well, y bar is the mean of the y's. So if you were to find the mean of all the numbers in list 2, the y values in list 2, it's a constant. The mean is constant. So the total deviation is the value of that y value minus the mean of the y values. Okay, so that's the total deviation. Y sub I minus y, the mean of the y's. Now, explained deviation is y sub I hat minus the mean of the y's. Now, y sub I hat is the y value on the regression line. So given the same x value, so if we wanted, let's say x sub I was 3, we have an observed value, that's what's in our chart, that's y sub I. But we can also have a predicted value. So y sub I hat is the predicted value. It's once on the regression line. So that's what this is. It's on the regression line minus the y mean, the mean of the y's. Now your explained deviation is the data, the original y sub I, minus the predicted y. So y sub I minus y hat. So we have a total deviation, the observed value minus the mean. Our explained is the predicted minus the mean, and the unexplained is the observed minus the predicted. Now, the total variation. The total variation is the sum of the squares of the differences between the y value of each ordered pair and the mean of y. So the total variation is the sum of the total deviation squared. Let me back up. Okay, the total deviation is y sub I minus the mean of the y's. That's the total deviation. So the total variation is the sum of all those squared. So you'd have to find all of those values and square it. Now our calculator is going to help us do that. We're going to use our lists to help us do that, but you need to know what it is we're doing. The explained variation is the explained deviation squared, and then we add all of those up. So again, the predicted value minus the mean of the y's. We're going to square each one of those and then add those up. Okay, so that's how you find explained variation. Unexplained variation is the unexplained deviations squared and then added up. It's the sum of the squares of the differences between the y values of each ordered pair and the corresponding predicted y value. So we just take those deviations and we're going to square each one of them and then add them all up. That's what we have going on there. Okay, so the sum of the explained and the unexplained variation is always going to equal the total variation. We have only two different types of variation. We have one that's explained and one that is unexplained, and that makes up a total variation. So we can find one or the other if we have two, just depending on which values we have. Okay? All right, the coefficient of determination. This is the ratio of explained variation to the total variation. It's the explained variation to the total variation. It's denoted by r squared. Okay, r is your regression coefficient, and if you square that, you've got the coefficient of determination. And that's the explained variation over the total variation. So in 9.1, we talked about the gross domestic products and the carbon dioxide emissions, and we found that the regression coefficient was 0.882. It's been a while probably since you've seen that, but we put variables in list 1 and list 2, and then we ran a lin reg, and it gave us our R. So find the coefficient of determination. What does it tell you about the explained variation of the data about the regression line, and what does it tell us about the unexplained variation? So R is 0.882. The coefficient of determination is R squared. So we're just going to square 0.882, and we're going to get 0.778. Okay? When you square this, you get 0.778. So what does that mean? That means that 77.8% of the variation in the carbon emissions can be explained by the variation in the gross domestic product. So 77.8% can be explained. The other 22.2% is unexplained. We're not really sure why there's that sort of relationship, that variance. We're not really sure, but 77.8% is an explained variation. So that is not too hard. The coefficient of determination is not too hard. We just need to find R and square it. Okay. Our standard error of estimate, however, looks a little bit scary. Okay. In the standard error of estimate is the standard deviation of our observed y value. So y sub I is our observed, about the predicted y value. So the predicted is y hat for any given x value. Okay, here is the formula. It is the observed minus the predicted squared, and we're going to add them up. The observed minus the predicted squared, and we're going to add them up. We're going to divide by n minus 2, and we're going to take the square root. Okay? It's a lot of squaring and adding and stuff, but we're going to use our calculator to do it. So let's take a look. So the first thing that we're going to want to do is we're going to want to make a table that includes the column heading shown at the right. So we're going to want to do xi's, yi's, predicted values. We're going to subtract and square. We're not going to actually, we're going to go, I believe, straight. We're going to skip this one and go straight to this one. We're going to create a regression equation, okay? And then we are going to add these up, and we're going to plug them into the formula. So let me walk through that step by step. So when we're finding the standard error of estimate, the first thing we're going to want to do is we're going to put our data values into list 1 and list 2. We've done that for this whole chapter. We're going to put x values in list 1, and we're going to put y values in list 2. And we want to get out of there. We want to exit out of the lists. That's important. Okay. Then we're going to find our regression line and store it in Y1. Stats, calculate linear regression, number 4. I'll show you how to store it here in just a minute. Then we're going to put the regression line into list 3. So what we're going to do is we're going to do y1, and we're going to do of L1. So what we're doing is we're going to put all these x values into the regression line. So we've stored our regression line into y1, and then we're going to take, our calculator's going to do this for us. It's going to take all of the x values in L1 and plug it into the regression line, and it's going to give all of our predicted y values. So all the predicted y values will end up in list 3. Then in list 4, we're going to subtract them. So we're going to take our observed y minus our predicted y, and we're going to square them. So our observed y we put in list 2, our predicted y we put in list 3. So we're going to have the calculator subtract L2 and L3, and then we're going to have it square it. And that will be sitting in list 4. Then we're going to have to exit out, and we're going to want to find the sum of list 4. So we're just going to run a one variable stats on list 4, and we can find the sum of our x's. Okay, they don't delineate, they don't call it yi minus y hat, they're just going to call them x's. So we're going to look for that. We're going to take that answer and divide it by n minus 2, and then we're going to take the square root. Okay, so let's take a look at an example. So, copy machine maintenance costs. A researcher collects the following data and determines that there is a significant relationship between the age of a copy machine and its monthly maintenance costs. So, what you need to do is you need to put the x's, the age, in list 1, and then you need to put the monthly cost, y, in list 2. So take a minute to pause the video and put these in list 1 and put these in list 2. All right, age goes in list 1, cost goes in list 2. When you've got it put back in, come back and we'll talk about it. Okay, so you've put the ages in list 1 with the corresponding costs in list 2. That's the first thing you're going to do when finding the standard error of estimate. Okay. The second thing we're going to do is we're going to find the regression equation, and we're going to store it in y1. So to do that, you're going to go to stat. Everybody's going to go to stat. Everybody's going to go to calculate, and everybody's going to choose for LinReg. Now TI-84 people, you've got this list. So we want to tell it list 1, list 2, and we want to store it in y1. Okay, TI-83 people, you're going to get a thing that says LinReg AX plus B right here. And you got to tell it list 1, comma, list 2, comma, y1. Okay, I'm going to get out of this for a second, and I'm going to show you how to find y1. Let me pull up the calculator. So let me go ahead and do this. I don't think that my, oh yeah, it is. So my list 1 and my list 2 are good to go. So let me go ahead to stat, and we're going over to calculate, and we're going to hit number 4, LinReg AX plus B. Now, everybody, I know that TI-83s, yours don't look like this, but you are going to have to put a y1 next to this. So this is how we get it. We're going to go to vars. We're going over to yvars because it's a y equation. We're just going to hit 1 or hit enter right there on the function, and we have a whole list. Well, let's store it into y1, so just hit enter. So that's where we get y1. Okay, and we're going to calculate that. Okay, look here. We've got our r, which is our regression coefficient, and we actually have r squared, which is our coefficient of determination. So you don't even have to square r. It's already right there for you. So what does that mean again? That means that 85.7% of the variation is explained, and the other, you can subtract that from 100. The other percentage is unexplained. Okay, so again, to get y1, vars over to yvars, hit enter for y1 for the function, and then we're going to hit enter for y1. And so that's how you find the y1 to either store your equation in or put it here for your TI-83s. Okay. So we put stuff in list 1 and list 2. We're running a linear regression line and we're storing it in y1. Okay, now we want to find the predicted y values in L3. So you're going to go over to L3 and you are going to type in y1 parentheses L1. This means that it's going to substitute 1 into the regression line. It's going to substitute 2 into the regression line. So you're going to find that y1 just like we just talked about. Okay, vars, go over to y vars, number 1 for function, number 1 for y1. Then parentheses, L1, second, L1, second 1, and parentheses, and then you will hit enter. When you do that, you'll have a whole list of numbers over here. Okay, and these will be the predicted values in list 3. Okay, so you should see this in list 3 now. It took all these 1 and plugged it into the regression line. Plugged 2 into the regression line. So these are our predicted y values. These are our y sub I hats. Okay. Now we want to find the observed y's minus our y hats, and we want to square them. So we're going to put that in L4. So go over and highlight L4, and you are going to do parentheses L2 minus L3 and parentheses squared. Parentheses second L2, which is number 2, minus second L3, which is number 3, parentheses squared. And you will hit enter, and then you will get an answer column here full of numbers. It's going to take 62 minus 63.696 and square it. It's going to take 78 minus 71.826 and square it. It's going to subtract these numbers and square them. Okay, so now we want to find the sum of L4 because our equation says it wants us to take the sum of our observed minus our predicted squared. So you're going to get out of there, exit out of the list, and we're going to run a one variable stat on list 4. So TI-84s, you have something that looks like this. Okay, stat, calculate, number 1 variable stat, put in list 4 here. TI-83s, you know, it comes to here, tell it list 4. If you don't tell it list 4, it's going to run information on list 1. So tell it list 4. When you run that information, look for the sum of the x's. That will be the sum of the data values in that list. So that's what you're putting in your calculator, and then we are looking for the sum of the x's, which is 169.73. Okay? So if you want to see that, I can show you. You can stat, we can go over to calculate, one variable stats. I'm going to tell it list 4, second number 4, and we're going to calculate. Okay, so we want the sum of the x's. That is the sum of the values in that particular list. Now we're not calling them x's, but that's what it is. Okay, so the next thing that you're going to do after you get those sums is you're going to divide that answer by 2. Also in that list you can see how many numbers you put in there. There were 6 data values, 6 ordered pairs. So 6 minus 2 is 4. So I took that answer and divided it by 4. You can round it. Round the sum of the x's. You don't have to type every decimal in. And then we're going to take the square root of that number. So there are a couple different ways you can do that. You can do the square root of second answer, or you can just use the square root of, and you can type that in yourself. So the standard error of estimate is approximately 6.5. Okay? It's long. It's a lot to remember. You're going to have to remember it. So make sure you do your homework so you're doing it over and over and over again so you can remember what to do. Okay, so look at that example a couple of times. All right, moving on to a prediction interval. A prediction, we've done prediction intervals before. I believe we did them before Christmas break. And we were able to use our calculator to find a z interval and a t interval. And then we did some intervals by hand for the chi-squareds. There again is not a calculator shortcut for this, so we have to do this ourselves. So given a linear regression equation, which you'll find using your calculator, mx plus b, for a specific x value, x sub 0, we're going to create a C prediction interval. Now, you should remember that you have some value that we're going to subtract an error from and some value that we will add an error from. So the actual value, the actual y value, will be a predicted value minus an error and a predicted value plus an error. Now this looks really scary. It does. It looks really scary. Okay, we already know how to find SE. And that took us a while. We had to use our calculator. We had to use a lot of things. It didn't take us as long as if we were doing it by hand, but we had to do that. TC is just a T critical value. N is the number of data points. X sub 0 is the X value that they're asking us for. X bar is the sum of the X's. This is the sum of the X squareds, and this is the sum of the X's. All of this comes from one variable stats. So what we're going to do is we're going to write a lot of stuff down, and then we're going to plug and chug. Okay, the point estimate is y sub I, and the maximum error of estimate is E. The probability that the prediction interval contains y is C. Okay, so the first thing we're going to do, I'd highly recommend you running one variable stats to find the sum of your x's, the sum of your x squareds, and the mean of your x's. So we're going to run a one variable stats on L1. Then we're going to create a regression equation so that we can find a point estimate, y hat. We're also going to find a t critical value. We're going to use either inverse t or the table 5 in the back of our book. The only difference is, ladies and gentlemen, that we have to really keep in mind is that our degree of freedom is n minus 2 this time, not n minus 1. So our degree of freedom is n minus 2. That's really important. Okay, it's not n minus 1, it's n minus 2. Okay, we're going to find our standard error of estimate if we haven't already done so. This one, I have walked through that, an example with you. We put stuff in list 1 and list 2. We found the differences, we squared, we did a lot of things. So if you don't remember how to do that, go back and watch the video. Now we're going to find the maximum error of estimate. We're going to plug all these numbers that we find into this equation. And then we're going to find our left and our right endpoints. We're going to take our y hat minus E and our y hat plus E. And that's going to be our interval. So let's walk through that. So we have the same set of data, so we're not going to replace any of the data that we just did. Now the instructions are to find a 95% confidence interval for the monthly maintenance cost of a machine that is 3 years old. So what range would the cost be for this copy machine? If it's 3 years old, how much is it going to cost us? What is a prediction interval? Okay, so we can find a predicted value on the regression line, but we want an interval. We want to say, oh, because there's always some sort of error that can happen, so plus or minus whatever. So what we're going to do is we're going to, first of all, plug values into list 1 and list 2. Now we've already done this because this is the same set of values. So, but to walk through this from start to finish, you would plug values into list 1 and list 2, and we would run a one variable stats on list 1. Okay? So when you do that, you find we need to write down the sum of the x's, we need to write down the sum of the x squareds, and we also need to write down the mean. Okay? We need to write down those three things. Those are things we're going to need to find our E. Okay, so we're going to write all those down on our paper. And notice that I'm rounding. Okay, you don't have to write everything down. Okay, another thing that's good to note, I thought about that after the fact, was to write down the n. Because sometimes we have a tendency to forget what our n is. So that's something we'll need for the formula too. So go ahead and write that down. Okay, now we've already found the regression line from our last problem. Okay, the last time we did it. So you don't have to walk through this again, but you guys know to find the regression, you're going to do linear regression on list 1 and list 2, and I would really like for you to store it in Y1. Okay, so you're going to find the regression line and use the given x value. In this case, we wanted a prediction value for 3 years. The copy machine is 3 years old, so we want to find the prediction interval for 3 years. So you find your regression line and you store it into Y1, and this is what you'll see on your calculator. Now what we're going to do is you're going to type in your calculator. You can clear it or whatever, but you'll type in Y1 of 3. Y1 of 3, and this is our predicted value. This is our Y hat. Okay, and so I rounded this to 80. I actually rounded it to the nearest tenth, but that rounded it to 80. I probably should have rounded it to 90.96, but I didn't do that. So we've got an 80 right there for the Y hat. So we run our prediction line, and then we take the given x value, and we plug it into Y1. So we're going to do Y1 of, in this case, 3, because that's what we're predicting. All right, now we want to find a t critical value that corresponds to the given confidence. So the degree of freedom is n minus 2. Now, if you're in the back of your book, looking at, we're not doing one-tailed or two-tailed now, we're doing the level of confidence. So go over to 0.95 because we wanted to be 95% confident. Make sure I'm on 0.95, there we go. 0.95, and you're going to go down to n minus 2, which in this case is 4. Okay. TI-84 people, you can do inverse T, and some TI-84s you can choose center for 0.95%. If you don't have that option, then you have to figure out what's in your left tail to be able to do that. I think the back of the book is actually much easier than the calculator on that one. So we get a T value of 2.776. Make sure it's always positive, please, in this case, because it's not a left tail, right tail test. It's just a critical value. We're using a positive T critical value. So again, back of the book, we are using, we're going to use the level of, it's backwards, the level of confidence, and it's 9.5. So we go find 0.95, and we go down to 4 to find our 2.776. Now we're going to find our standard error of estimate. I'm not going to walk through that all with you. This is the same problem, same set of data, so I just wrote down what we found in the last couple of slides. But if you again need to review how to find the standard error of estimate, go ahead and back up the video and watch how to do that again. Now we're going to find the maximum error of estimate. So this is a big formula, but we have values for all of this now. We've written down TC. We've written down SE. We've written down N. We know that X sub 0, that's always what's given to you in the problem, is 3. We wrote down X bar. We wrote down the sum of the X squareds, and we wrote down the sum of the X's. So here's the formula, and this is all the stuff that we wrote down. Okay? So what I'm going to do is just plug these numbers in here. So in for TC, 2.776 times, let me do this, times SE. 1 plus 1 over n plus n parentheses x sub 0. Now, when you plug this into the calculator, if you want to do it all together, you will need parentheses on the top of this, and you will need parentheses on the bottom of this. If you forget the parentheses, you're not going to do it right. So if you're plugging it all in your calculator at one time, okay, you will need to make sure that you put parentheses in the whole numerator and parentheses in the denominator. This is also a times, so we need to be careful of that. Pretty much everything else is the same. So I've got 2.776 for t times 6.5 for SE, the square root of 1 plus 1 over 6 plus 6 times 3 minus 3 was our x sub 0. 3.33, that's our x bar, squared, over 6 times 82, that was the sum of our x's squared, minus 20 squared. This is the sum of the x's, which is 20, and we're going to square it. Okay? So, when you put this in your calculator, it's not, some calculators have the ability to write it vertically like that. Mine does not. So, when you see it, it's all going to be linear. Some calculators give you a parenthesis in front of this, so you'll need that. Again, you're going to need parentheses for the top and parentheses for the bottom, and it's going to be one long equation in your calculator. Okay. Okay, so now we're going to find the left and the right endpoints. So again, we've got a predicted value. That's when we plugged y number 3 into y1, and we just found our e on the last slide. So our predicted y value, if you'll remember, was 80. So write that down on a sheet of paper. So that, it's a lot easier when you're on one sheet of paper, all that stuff is there. And the e that we just found was 19.55. So we're going to take that predicted y value, 80, and minus the 19.55. And we're going to take that predicted y value and add the 19.55. So we get 60.45 is less than y is less than 99.55. So we are 95% confident that the intervals 60.45 is less than y is less than 99.55 actually contains the value of y. Now in this case, y stands for the cost of the copy machine. So we're 95% confident that the cost for this 3-year-old copy machine is between $60.45 and $99.55. So that's where we are. Okay. Lots of stuff today, so you may have to watch this a couple times to get it. You might have to pause it a couple times, and that's okay. Okay? All right. I love you guys, and I will talk to you later. Bye.